Okay, here we have a particularly tricky redox calculation for you to tackle here. So this is a big 7-mark calculation with quite a lot of information for you to try and digest, a lot of information for you to try and work through. So a bit of logical thinking, a bit of ordering of your thoughts is necessary to solve this problem. It's not going to be easy. It's going to take all of your brain power to get through this one. So a student carries out an investigation into the oxidation states of vanadium outlined below. A 0.126 gram sample of vanadium metal is completely reacted with acid to form a yellow solution, and the solution is made up to 50 centimeters cubed in a volumetric flask. This yellow solution contains vanadate VO3- ions with the vanadium in the +5 oxidation state. And you can see that here. Think about your oxidation number rules. Oxygen in a molecule or combined oxygen is always -2. There's 3 lots of -2 to give -6. There's a minus charge on the ion overall, so the vanadium must be +5. The yellow solution is reduced to form a violet solution of Vn plus ions. This 50 centimeter cube solution contains vanadium in the +N oxidation state. So you've got a clue here. You can probably see where they're going to go with this. You're going to have to work this out. 10 centimeters cubed of the violet solution is titrated with 2.25 times 10 to the -2 mole per decimeter cubed potassium permanganate. And we've got 13.2 centimeters cubed is required to reach the end point. Some information about the titration. So we're being told here in the titration that these mysterious Vn plus ions are being oxidized back to the vanadate ions again. Okay, so you've got the reaction to make the vanadate ions. Okay, they are then reduced to the Vn plus, and then in the titration they're put back to the VO3- again. And as a result of that, the MnO4- ion is reduced to the manganese ion. Analyze the student's results. Now that is the crucial question, the crucial word in the question. Analyze the student's results. You've got to properly dig through the information you've been given and figure out what it is going on in there and figure out how all the quantities relate to each other. So analyze the student's results as follows. Determine the value of N in Vn plus for in stage 2 and construct an equation for the reaction that takes place during the titration. Show all your working. Right, there's 2 parts to this, but really to solve N, you need to find the equation to a certain degree. Okay, so there's quite a lot of information, there's quite a lot of working out to do for this question. So job 1, go back through the 3 stages and sort out what on earth is going on in this actual problem. Let's start here. We've got a mass of our vanadium metal. Okay, so from there, I've possibly got the ability to work out a number of moles if I need to. Let's carry on looking through. 0.126 gram sample of vanadium metal is completely reacted with acid to form a yellow solution. The solution is made of 50 centimeters cubed in a volumetric flask containing the vanadate ions now. This yellow solution is reduced to form a violet solution containing Vn plus ions. Same quantity. And then we take 10 centimeters cubed of that to carry out the reaction. So you can see here, I have a number of moles in my mass of vanadium here. Okay, that will be the same number of moles that we have for our vanadate ions here in the 50 centimeters cubed. Exactly. So if I work out moles here, that will be the equal number of moles of that, which will also mean I know how many moles of Vn plus I've got. So you can see how here everything's going to start to link together. Despite the fact we've got multiple reactions going on, the number of moles of the vanadium, the vanadate, and the Vn plus, there's only one V in all of them. So it has to be the same. Okay, so that's probably a good place to start this calculation off, is can we work out a number of moles of our vanadium. We've also here got, in stage 3, a concentration and a volume for the potassium permanganate. So I can also work out a number of moles here. And that should always be a first port of call for any of your calculations. Look through the information and decide if you can work out the number of moles of something or more than one thing. Now in this case, because we're being asked to construct an equation, we're going to need to know the reacting ratios of whatever this vanadium compound is and the manganese. So we're going to have to work out the moles for both to be able to determine the equation in the first place. Okay, so let's start here then. Move the questions up a little bit. So let's work out our moles of vanadium, which therefore is equal to the moles of vanadium VO3-, the vanadate ion, which is also equal to the number of moles of the Vn plus. Okay, which is mass of a molar mass, so 1.26 grams divided by 50.9 which is the molar mass or the atomic mass of a vanadium atom, gives me 0.00247 moles. Okay, so this is the moles that was present in the 0.126 grams of vanadium, which is therefore the number of moles that went into the 50 centimeter cube flask containing the vanadate ions, which is also the number of moles that was present in the 50 centimeters cubed of the violet solution when we changed the vanadate to the Vn+. Okay. But the question, bring this back down again, down here, when we look at stage 3, it states that 10 centimeters cubed of the violet solution was titrated. So whilst we've got the number of moles in the original 50 here, and the original 1.26 grams, that's not going to be the number of moles that's present in that value there. Okay, we've got a fifth of the original solution. So therefore, we can carry this on. Therefore, the number of moles of our Vn plus in only 10 centimeters cubed, which is what was used in the titration, will be 0.002475 divided by 5, because this value is in 50 centimeters cubed. And we want it now for 10, because that's going to be the value that the titration was done based on. Okay, which will give us 4.95 times 10 to the minus 4 moles. So now we've got our moles of the Vn plus ions that were reacted in the actual titration in stage 3. So I can also now calculate the number of moles of the potassium permanganate. We've got the concentration and volume there, so we can do that next. Number of moles of the KMnO4, concentration times volume over 1,000. So we've got 2.25 times 10 to the minus 2, multiplied by the volume, 13.2, the average titer. Divide that by 1,000, which will give us 2.97 times 10 to the minus 4 moles. Okay, so from the information I've got here, that is all I can do from the numbers I've been given here. I've got moles now of the vanadate ions that were involved in the titration, and I've got the moles of the manganate ions that were involved in the titration. So we've been given the half equation here to indicate what's happening to the manganate ions in the titration, but we've got nothing other than a statement here telling us what's happening to the Vn+. We know Vn+ is oxidizing back to the VO3-, therefore the MnO4 is reducing to Mn2+. So this stage 3 is what we're trying to figure out the equation for, okay? So it's asked us to work out the equation for the reaction takes place in the titration. So it's this relationship between the moles of the vanadate ions, not the vanadate ions, the moles of the Vn plus ions here against the manganate ions. Now we've got, from these initial calculations, we'll just move these out of the way. We've now got, from our initial calculations, our moles of the Vn plus, let's move the n to the right place, the Vn plus there, and here is the moles of the MnO4 minus, the potassium permanganate or the manganate ions, which is the important bit. So what we need to do now is figure out the reacting ratio between these. We know in the titration that the manganate ions are reacting with the vanadate ions, but what we don't know is what the ratio is of those in the actual equation itself. So that's what we need to do now, is determine the reacting ratio. Now all you do then is divide them both by the smallest. So you get a ratio then of 1 to something, and if that doesn't come out as a whole number, then you scale it up until it is a whole number. So it's almost like an empirical formula style calculation. Divide by the smallest to get a ratio. That's what we have to do then. So if we go for the reacting ratio, just label this calculation as that. The reacting ratio, it's going to be, not Russian, ratio, is dividing both by the smallest. Okay, so clearly 2.97 times 10 to the minus 4 is smaller than 4.95 times 10 to the minus 4. So if I divide that by itself, it's 1. So I divide 4.95 times 10 to the minus 4 by 2.97 times 10 to the minus 4. That will give me a ratio then of 1.67 to 1. Okay, so obviously I can't use 1.67 in an equation, so I need to scale this up until we get whole numbers. Okay, so the simplest whole number ratio here is going to be 5/3. Okay, multiply both by 3 and we'd end up with 5/3. So that tells me then, so what we've got here is, this is the Vn plus over the MnO4 minus. So 5 moles of the Vn plus ion will react with 3 moles of the MnO4 minus ion. So this is now going to start to help me construct my equation and then also figure out what the N is. So what we can do now is start to construct the two half equations. We've got one of them already. One of them was given to us on the question originally. So we've got the half equation here for what's happening with the manganate ions, and we've got information telling us what's happening to the vanadium ions here. Okay, so let's start off with the manganate ion. Let's just write it on here. We've got MnO4 minus plus 8H plus 5E minus gives us Mn2 plus and 4H2O. And also we know then that in the other instance, the vanadium ions, this unknown Vn plus ion, is oxidizing to the vanadate VO3 minus ion. So obviously the electrons will be on this side of this equation, but at this stage we're not overly sure of how many. So this is where we now use our reacting ratios. We know that 5 moles of the Vn plus are going to react with 3 moles of the MnO4 minus. Okay? So that must mean if 3 moles of the MnO4 minus are reacting, then each one of these manganate ions is going to gain 5 electrons. So if there's 3 of them in the reaction, because we've got 3 to 5 ratio, 3 of these are reacting, that means in total 15 electrons will be gained by the manganate ions, by the 3 manganate ions, each one gaining 5. Therefore, 15 electrons will be gained. And in any redox reaction, the number of electrons being gained and lost have got to be the same. So in this case, for the vanadium to the vanadate, 15 electrons in total will be lost to make sure that the charges equal up and make sure that all the electrons are accounted for. Now, because we know from here that 5 moles of the Vn, the Vn plus ion, the vanadium ion, are reacting, we can now use that to determine then, well, how many electrons are lost by one of them. So if 5 moles are reacting, and we need to lose 15 electrons in total, 5 times 3 is 15. That must mean that each vanadium ion must be losing 3 electrons to make the total of 15 electrons that can be lost. All right, just going through that one more time. From the reacting ratio here, we know that 5 moles of Vn plus are reacting with 3 moles of MnO4. So each individual MnO4 ion will be gaining 5 electrons. If 3 are reacting in total, therefore 15 electrons will be gained in total by the MnO4 minus. Therefore, we know 5 moles of the Vn plus are reacting, so each one will have to lose 3 to make the 15 electrons in total. Now we know that we can start to construct the full half equation here, because at the moment we haven't got a full half equation. We haven't got any oxygen, we haven't got oxygens over here, so it can't be full. But we do now know that each one of these is losing 3 electrons, so we can now use that information to figure out what this is going to be. So if we complete the half equation first, I've got oxygen over here, so that must mean I'll have water over here to compensate for that. And because there's 3 oxygens, I will need 3 waters. And now I've got 6 hydrogens over here, so I'm also going to have, let's put underneath here, 6H plus on this side. So now I've got my full equation, but I still don't know what the charge is going to be. But now I know exactly what's going to be in this equation, I can work it out, because we know that in any equation, atoms and charge has to balance. So in total, on this side of the equation, I've got a 6 plus, 3 and 1, 4 minus. So 6 plus, 4 minus, in total, gives me a 2 plus charge on the right-hand side. So therefore, the charge on the left-hand side has got to equal 2. There's no charge on water, therefore that has got to be a 2 plus ion. So we have solved it. We therefore know, based on this, that N has got to be 2 plus. All right, and that actually makes sense because when you learn your transition metals and your colours of your transition metals, a vanadium ion with a 2 plus charge is violet. That is the colour of that particular solution. So if you knew your colours, you would have known that N is plus 2, but you still have to calculate it mathematically. The whole point of this question is you're proving it using your maths. So we've now done that. We've proven that it's 2 plus. We can now construct the overall equation. So to construct the overall equation, we need to make sure that the electrons are equal, and we know we need to have 15 on each side. So we're going to cross multiply. We're going to multiply this top reaction by 3, because we know that 3 manganate ions are reacting. And we're going to multiply this reaction by 5, because again we know that there's 5 vanadium ions reacting. Okay, so if we put these numbers in, that's now going to make 3 MnO4, 3/8 times is 24 hydrogens, just overwrite the 24 there. That give me 15 electrons, 3 Mn2 plus, and 3 times 4 is 12 waters. And likewise here, 5 times 3, 15 waters, 5 Vn plus, 5 VO3 minus, and 15 electrons. So we write that out in full. Remember, when you combine two equations, you combine the left and the right and then cancel down anything that appears on both sides. So in full, we have got 3 MnO4 minus plus 24H plus 15 electrons plus 15 H2O plus 5 Vn plus, so V2 plus now, we know it's 2 plus, let's ignore the N plus, will produce 3 Mn2 plus 12 H2O plus 5 VO3 minus plus, oh I missed the H pluses there, sorry, 6 times 5 is 11, no it's not, 6 times 5 is 30, I'll do that, 6 plus 5 is 11, so 30 H plus. Okay, so there's the full equation. Obviously we can cancel things down now, so the electrons can cancel because they're on both sides. Let's remove those. I've now got water on both sides. There's 12 waters over here and there's 15 over here, so that's going to cancel that down to 3, leave me 3 H2O, 24 hydrogens, 30 hydrogens, so they're all going to go, and it's going to cancel that down to 6. So rewriting the equation, 3 MnO4 minus plus 3 H2O plus 5 V2 plus will produce 3 Mn2 plus 5 VO3 minus plus 6 H plus, and there's your equation. Okay, and there we go. That's a very, very tricky calculation. You can see there's lots and lots of working out to do there. But thinking about a logical process, starting off at the beginning, look at the numbers given to you in the question, work it through bit by bit, look at what you've got, what can you work out from that. You've got 2 instances of your workout moles, and whenever you're being asked to work out what an equation is going to be, you know you're going to have to do this. You know you're going to have to work out your ratio. So be mindful of that, and that's done by dividing by the smallest. Okay, and here the charge, remember, was worked out by figuring out, once you've ratio, you know how many particles you've got reacting, you can figure out the total number of electrons that are being lost and gained, and the charge will just drop into place from there. And then your overall equation is constructed in the normal way. So take some time, go through the video as many times as you need to. If it's still not making sense, come and find me in college and I will help you out again.